Hi, thanks for joining me. This is Astronomy Daily. I'm your host, Andrew Dunkley. Coming up today, a Comet Interceptor mission. Nothing to do with DART or the plans of the Chinese that we talked about last week. This is another new mission. Also, the solar system has a magnetic tunnel, and we look at space junk because it's getting so junky up there, something's going to go wrong, according to one expert. That's all coming up on this edition of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
And we say hello to our AI reporter, Hallie. Hi, Hallie, what's news?
Oh, okay. No faffing around today, I guess. Comet strikes on Jupiter's moon Europa could help transport critical ingredients for life found on the moon's surface to its hidden ocean of liquid water, even if the impacts don't punch completely through the moon's icy shell. The discovery comes from a study led by researchers at the University of Texas at Austin, where researchers developed a computer model to observe what happens after a comet or asteroid strikes the ice shell, which is estimated to be tens of kilometers thick. The model shows that if an impact can make it at least halfway through the moon's ice shell, the heated meltwater it generates will sink through the rest of the ice, bringing oxidants, a class of chemicals required for life, from the surface to the ocean, where they could help sustain any potential life in the sheltered waters. The study is comparable to the news we discussed yesterday about Saturn's ice moon Enceladus having all the ingredients for sustaining life beneath its surface. NASA conducted the first test of the newly redesigned RS-25 engine for future flights of the Space Launch System rocket, completing 209.5 seconds of a scheduled 500-second hot fire at the agency's Stennis Space Center, near Base St. Louis, Mississippi. The hot fire test was shut down early by a non-flight system used to monitor the engine. NASA and Space Launch System lead engine contractor Aerojet Rocketdyne are analyzing data to review the monitoring system, evaluate engine performance, and identify the reason for the early test cutoff. Because the test was being done for redesigned engines in support of Artemis 5 and beyond, no impacts to RS-25 hardware for earlier missions is expected. The single-engine hot fire, known as a confidence test, was designed to confirm all is ready to proceed with a series of certification tests early next year on a full RS-25 certification engine. Scientists analyzed new measurements showing that the light emitted by stars outside our galaxy is 2 to 3 times brighter than the light from known populations of galaxies, challenging assumptions about the number and environment of stars are in the universe. Results of the study led by researchers at Rochester Institute of Technology have been posted to AR14 and accepted for publication in the Astrophysical Journal. The research team analyzed hundreds of images of background light taken by the Long Range Reconnaissance Imager on NASA's New Horizons mission to calculate the cosmic optical background, the sum of light emitted by stars beyond the Milky Way over the history of the universe. If the COB brightness doesn't equal the light from galaxies we know about, it suggests there might be missing sources of optical light in the universe. And that's the news, Andrew.
Thank you, Hallie. We'll catch up with you shortly. Now, we've talked about the DART mission, and we've talked about a mission that China is looking at to intercept an asteroid. Well, now another agreement has been signed looking at a similar situation, but this one's a little bit different. ESA, the European Space Agency, and OHB have signed a contract to move forward with the design and construction of ESA's ambitious Comet Interceptor spacecraft, which they plan to launch in 2029. Now, this is unlike other missions. Comet Interceptor's target has not been defined yet, and that's because it would take too long to build a mission on the short time frame of a potential target entering the solar system for a spacecraft to reach that particular comet in time, whatever that comet would be. Instead, Comet Interceptor will be ready, and unless a suitable target is identified before launch, it'll wait 1.5 million kilometres behind Earth as viewed from the Sun at the gravitationally stable Lagrange point 2, and it'll wait for a suitable comet or even an interstellar object to enter the solar system for the first time, and then it'll go and check it out. Once a suitable comet or interstellar object is identified, Comet Interceptor will be deployed from its parking station and set on an intersect trajectory. The mission comprises 3 modules, a main spacecraft and 2 probes, and they'll separate several days prior to the interception of the comet to perform simultaneous observations from multiple angles, creating an exceptional 3D profile of the comet or object or whatever it turns out to be. ESA is leading the development of the main spacecraft and one of the probes, both carrying different but complementary instruments built by European scientific institutes and industry. JAXA, the Japanese Aerospace Exploration Agency, is providing the other probe and its instruments. Comet Interceptor was originally proposed to ESA in July of 2018, and it was selected 11 months later. It's an example of a fast development or F-class mission, they say. Comet Interceptor is foreseen for launch as a co-passenger with ESA's exoplanet-studying Ariel spacecraft in 2029. Now, the solar system is something we know quite well, but then occasionally we'll hit a curveball and think, well, how come we didn't know that? And that's what this story is about, because they've discovered a magnetic tunnel. Well, they're not so much discovered it, but they are redefining what this could be, because there's been a relationship between 2 different things that looks like they interact. A University of Toronto astronomers' research suggests the solar system is surrounded by a magnetic tunnel that can be seen in radio waves. Jennifer West is a research associate at the Dunlap Institute for Astronomy and Astrophysics and is making a scientific case that 2 bright structures seen on opposite sides of the sky, previously considered to be separate, are actually connected and are made of rope-like filaments. The connection forms what looks like a tunnel around the solar system. Now, the results of West's research have been published in the Astrophysical Journal. Called the North Polar Spur and the Fan region, astronomers have known about these 2 structures for decades. West says that most scientific explanations have focused on them individually, and she and her colleagues, by contrast, believe they are the first astronomers to connect the dots, or connect these 2 things as a single unit. Made up of charged particles and a magnetic field, the structures are shaped like long ropes. They're located about 350 light years away from us and about 1,000 light years in length. West has been thinking about these features on and off for about 15 years, ever since she first saw a map of the radio sky. More recently, she built a computer model that calculated what the radio sky would look like from Earth as she varied the shape and location of the long ropes. The model allowed West to build the structure around us and showed her what the sky would look like through our telescopes. And it was that perspective that helped her match the models of the data. An expert in magnetism in galaxies and the interstellar medium, West looks forward to more possible discoveries connected to this research. West says magnetic fields don't exist in isolation. They all must connect to each other. So the next step is to better understand how this local magnetic field connects both to the larger scale galactic magnetic field and the smaller scale magnetic fields around our Sun and Earth. In the meantime, West agrees that the new tunnel model brings new insight to the scientific community.
The Astronomy Daily Podcast
with Andrew Dunkley.
Now to the trouble with space junk. Up until a decade ago, there were an average of 80 to 100 satellites per year launched into various orbits around our planet. Some re-entered Earth's atmosphere pretty quickly, others remain for decades. This now seems quaint compared to what's been happening for the last 5 years, driven largely by the rise of communication networks like SpaceX and Starlink and a whole bunch of other small satellite operators. In 2017, the United Nations Office for Outer Space Affairs said the annual number exceeded 300. By 2020, the annual number of objects launched exceeded 1,000 for the first time. This year, the total has already surpassed 2,000, with more broadband from space networks like Amazon's Project Kuiper on the way. Those numbers are expected to climb. The radical increase in the number of satellites, most of which are orbiting within 1,000 kilometres of the surface of the Earth, comes as low Earth orbit is becoming more and more cluttered with debris. Last month, you might remember, China's Long March 6A rocket's upper stage unexpectedly broke apart after delivering its payload into orbit. There are now more than 300 pieces of trackable debris at an altitude of between 500 and 1,000 kilometres. In November of 2021, Russia shot down its own Cosmos 1408 satellite, creating more than 1,000 fragments in orbit, and they were criticised heavily for it. NASA's International Space Station has to regularly dodge this kind of debris. So scientists and engineers estimate that there are hundreds of thousands of pieces of orbital debris about the size of a berry that cannot be tracked. Given their velocities, and we're talking many times the speed of sound, these small objects have the kinetic energy of a falling anvil. Then there are the tens of thousands of pieces of trackable debris the size of a cricket ball, softball, tennis ball, or larger, that have the kinetic energy of a large bomb. While some of this debris gets dragged down into the Earth's atmosphere and burns up every day, humans are rapidly creating more of it. So what's going to happen? Well, nothing good, according to Moriba Jah, an astrodynamicist from the University of Texas at Austin. Jah is an expert in the field of orbital debris and one of the foremost critics of the rising tide of space junk, and he's calling for humanity to preserve low Earth orbit. In an interview with the Ars Technical website, he said, "Right now, there is no coordination planning. Each country has plans in absence of accounting for other countries' plans, and that's part of the problem." Jah predicts that if things keep going the way they are, certain orbits will be lost due to the saturation of material around the planet. And he fears there will be incidents or accidents in space if authorities don't come together on the issue. The biggest problem is that the current laws only make nations, countries if you like, responsible for space, not the private companies that are most responsible for the proliferation of material being hoisted into orbit. It sounds like the laws need to be changed and changed very, very quickly. But who's going to take responsibility for that, one wonders. You can find those stories on our website, astronomydaily.io. You can also sign up for the newsletter and get your astronomy news every day through your email inbox. And don't forget to visit spacenuts.io. Catch up with the latest episodes of Space Nuts, the most recent being a Q&A episode where we took audience questions with Professor Fred Watson, astronomer at large. That just about wraps us up for another day. Hallie, what have you got before we go?
I gotta run. Have to do some shopping.
Shopping? What's on the shopping list?
I'm out of coffee for starters.
Oh, really? What kind of coffee do you drink?
Java, of course.
Very funny. Bye, Hallie.
Bye.
Until next time, this has been Andrew Dunkley for Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.